One more time, welcome everyone to Cloud Data Driven. Okay. It's always a pleasure to have you. Thank you for joining us. And we have Kevin Feasel today. And Kevin Feasel been supporting us since day one. Thank you so much, Kevin, for all your support. And thank you to all attendees, wherever you are. We welcome you one more time. And just for your information, our third editions of Feature Data Driven is already scheduled for this September. So if you do want to join our community and register for that event, this is the way to go. And how can you access to this website? All you have to do is to type datadrivencommunity.com. Once you type it, that's what you're gonna get. If you want to join us weekly, this is where you can do that. If you want to register for Feature Data Driven, this is where you can do that. And for next week, we have Andreas that's gonna walk us to metadata to Lakehouse. But what an amazing session. So I would highly suggest you to register and join us if you haven't done so. And then we also have Feature Data Driven. If you want to register, feel free to scan this and register. And also, don't forget to share this event with your peers, your coworkers, your friends, right? There will be over about 30 different data professional experts, people from the data community, and even people from Microsoft. By the way, you guys know me. I'm the founder and the main organizer of this community, and I work for Microsoft as a technical trainer. So therefore, we have people coming from Microsoft as always, right? So I would suggest you to go and join us and learn from the community. Great. If you do want to speak, feel free to submit it. The call for speaker is still open. It will be closed on June 3rd. So we don't want to miss you. If you do have some good session you want to share with the community, this is the time for you to submit it. Once the call for speaker is closed, we're going to have to wait to listen to you next year. And this year, this time is your time to submit your session. Feel free to do that. Great. As you know, we have Kevin. Kevin will talk about what we call Data Explorer with Synapse. And Data Explorer is one of my favorite tool, right? Kevin, one more time, thank you. Feel free to share the screen, introduce yourself, and start with the presentation.
All right, let's do that. And I'm going to make sure that chat is right in front of me. So if you have any questions as we go through, please feel free to put them in chat there. So welcome everybody to Data Exploration with Synapse and KQL. And by the way, if you hear the bird chirping in the background, do let me know. It's right outside the house, so I can shut a window. But if you don't hear the bird chirping, that's fine. That's even better. So my name is Kevin Feasel. I am the proprietor at a consulting company called Catalyxy Services, LLC. I've been doing that for a long time, and now I'm doing it full time. I also have a blog called Curated SQL, where I try to find and link to 5 to 10 interesting posts per day on topics all across the data platform space. So that's curatedsql.com. What I would like to do in this presentation is to first introduce Synapse Data Explorer and talk a little bit about why we would think of Data Explorer in a solution for modern data warehousing. I'll introduce the language KQL, and a lot of this session is going to be a walkthrough of the Kusto Query Language, show you how to perform some queries with that language, including doing some time series analysis, and wrap this up with a few recommendations on writing queries that will perform a little better. So let's start off by talking about Synapse Data Explorer. And before I really dig into that, I want to give a level setting on Azure Synapse Analytics as a full product. So this is Microsoft's platform for modern data warehousing. And there are 4 major components to it that I'm going to focus on here. The first is the dedicated SQL pool. This is a massive parallel processing approach for data warehousing, and generally it has a fairly tall, you must be this tall to ride the ride set of requirements, in that you're using a Kimball style fact dimensional warehouse. That's not a requirement, but that's a very strong recommendation. You should have at least 1 terabyte of data. Your biggest fact table should have at least 1 billion rows of date and numeric data. And dimensions should typically be small, but fairly
Kevin,
wide. Yes, is it
you're
not
not
sharing
sharing your
correctly?
screen. No, you're not
I am
sharing your
sharing,
screen.
but this is the new Teams. So what I'm going to do is switch back to the old Teams. I'll be back in just a moment.
No issue.
Okay, I'm back. If you could re-enable me as a presenter, I can get going again.
Let me quickly do that.
Okay, while you're doing that, basically, I've had this problem a few times with the new Teams, and it's good, except when, it fails in presentations like this. So I'm back on old Teams. I'll be able to share screen, and this time everybody will be able to see it, hopefully.
I haven't seen it. Can everyone else confirm if if this is for
Well,
mine?
no, I can't share screen yet. You have to raise me up as a presenter again.
Okay, perfect. Just give me 1 second. For some reason, it's slowing down, Kevin. Hold on. I see. Okay, perfect. Give me a second. I can see you in order for, I'm not sure if this is for my end. Just give me 1 second, Kevin. Not sure why am I getting this. Sorry for the technical issue, team. I'm not sure what is going on. Give me a second.
That's all right. While Jean is getting that sorted out, so dedicated SQL pools generally are going to be that classic data warehousing scenario. By the way, yes, I know some of you weren't able to see the slides. Right now, that was just a big wall of text, so you're not missing too much. Basically, users are going to work off of some set number of queries. They're going to have a really good idea of the types of queries that they want to run, the types of data that we're going to work with. And this is our classical scenario of data warehousing. And this is a way for us to implement that in Azure Synapse Analytics at some reasonably high scale. So now, if there's anybody who's not able to see the screen, please do let me know. But otherwise, we're going to pick back up as though that never happened. So let's talk next about Spark pools. Spark pools, you can spin up a Spark cluster, just like the name suggests. We may use Spark clusters for things like complicated data transformation. We're going to do some intense ETL operations, things like working with regular expressions, stuff that we can't really do in T-SQL. Distributed machine learning tasks that don't quite fit under the aegis of Azure Machine Learning. If we're using Spark very heavily, that's not quite where Azure ML is in its wheelhouse. And if you have things already running in Spark clusters, either on premises, you're using HD Insight, I would suggest using Databricks, but that's a different story. Databricks has a better Spark experience. Nonetheless, if you're migrating work over, that works. So dedicated SQL pool spent 5,000 in April alone. We're not using it yet, just set up. What have we done wrong? You're running it. So as long as the pool is running, if it's not paused, you're paying for it, regardless of whether you're actively using it or not. Now, the serverless SQL pool, a little bit different, doesn't store data. You read files directly from a data lake instead of having that database available to you. There's no infrastructure, there's no resource reservation, no upfront costs. So very much to the question that Gabriel had here. The pricing model for the serverless SQL pool is on data access, data utilization, about $5 per terabyte of data processed. I have a whole talk on the serverless SQL pool. I think it's a pretty neat idea, but that's for another day because we're focusing on Data Explorer. Data Explorer pools are going to allow you to do real-time analysis on large volumes of data. And the initial use case of this was processing log data. So we see that in log analytics. We see that in application insights. In both of those scenarios, you're able to store data in a Kusto database. You're able to query it using the Kusto Query Language, and it's really intended for log analysis. For Data Explorer pools in Synapse, we could do log analysis, but the concepts of the language actually apply really well to event processing and to time series analysis. Now, because I already got a question about pricing, I think it's an important thing to talk about. Synapse pools typically price on two things, compute and storage. So for a dedicated SQL pool, you pay for that compute. You're also paying for the storage in a storage account. For the serverless pool, you're paying for the storage, however much data you have there, plus the data processed. For Data Explorer, compute is based on vCore hours, and storage is based on terabytes of data stored per month. When I put together these slides, I think this was last year. It was April of last year. So the prices I don't think have changed, but just in case. It cost about 21.9 cents US per vCore hour, and it was $23.04 per terabyte per month. So if you say, I need 8 vCores, I need 50 terabytes, one instance, so no high availability, we're looking at roughly $2,400 per month to run this Data Explorer pool. These numbers are just numbers I pulled out of a hat. These are not necessarily the numbers that you'll need or the numbers that you'll be able to make use of. Your situation will differ, of course, and based on that, you may find that you're paying a lot less or maybe a lot more. The Azure pricing calculator does lay this out for you, so you can get more details there. Now, let's say that we want to create one of these. The way to do it is, first, you have to have a Synapse workspace. Once you have a Synapse workspace, you can select Data Explorer Pools, which is still in preview. It was in preview when I took the screenshot. It's still in preview today. And then choose New and create a new Data Explorer pool. To do this, we are going to give it a name. So I chose the name CSDE. We're going to pick a workload. The workload is one of a couple of options. And the one that I selected here is compute optimized. Within that workload, we get to choose a size and number of cores. I chose extra small for this demo, and as we'll see, the demo results are going to be fine. As you get larger and larger loads of data, as you get more concurrent users, you may want to bump up to additional cores. So those additional vCores are going to cost you more. Notice that there's no clean slider of like 0.5 vCores up to however many when you're selecting compute optimized. For Synapse Data Explorer, you're kind of locked into these are the numbers of cores that I have available. Then we can have autoscale. If you want high availability, it's actually pretty simple. If you want the ability to scale out horizontally as more users hit your systems, basically it's a selection here. So I can toggle either manually to scale or to enable auto scaling. With auto scaling, there's a minimum instance count and a maximum instance count. So the SKUs of server that I chose as you can see in this error message, had a minimum instance count of 2 and a maximum count of 8. So my 0 to 3, basically I can't choose 0. I had to choose 2 and 3 if I want auto scale. There are a couple of other options down at the bottom here that can affect cost, and that is streaming ingestion and purging. So streaming ingestion is going to be a listener for, are you regularly feeding in data, or is it going to be more batch operations? If you're regularly feeding in data, you got to pay for that listener. Purging will get rid of data after a certain amount of time, so that way you're not paying those storage charges perpetually. I may, for example, want to store my data for 1 year and then get rid of it or migrate it off to just a regular storage account where it's going to be a lot cheaper. So purge will handle auto deletion of data as it expires. So now I want to talk a little bit about loading data into Data Explorer. And this part is going to be mostly screenshots because the loading process can be a little convoluted at times, especially as you get more and more files. So for a small number of files, it's not bad. For a larger scale scenario, it's not something I wanted to set up and try to demonstrate on a repeated basis. First thing we're going to do, we have our Data Explorer pool. Well, now we need a database as well. Data Explorer pools have databases. Those databases are going to have tables. Those tables are made up of rows and columns. We're familiar with SQL Server, very similar conceptually, very different in terms of practical implementation, but as far as concept goes, the pattern matches. In order to create a database on a brand new pool, I can select this option to create database. And that's going to take me to the Azure Data Explorer creation process. So we see it's called an Azure Data Explorer database. Synapse Data Explorer and Azure Data Explorer are essentially the same code base. I believe there might be some underlying differences between the two, but essentially 90-something% of what's in Synapse Data Explorer also exists in Azure Data Explorer and vice versa. This is similar to Synapse Pipelines and Azure Data Factory, where I don't think it's an exact code match, but functionality-wise, it's really similar. So I create a new database for my Synapse Data Explorer pool. I'm going to give it a name, CSDE-DB. I'm going to have a retention period. That retention period is for automatically purging my data after a certain amount of time. Now, in practice, I checked that box to say unlimited days for retention period because I want to keep this demo around for as long as I'm presenting it. So I don't want that data to go away. I also have the option for caching. This cache is putting the data on faster disks. That way your query responses will be significantly faster versus the slow disk. As I recall, caching is SSD and normal retention is spinning disk. So a common pattern for this, especially if you're thinking about a log or a short-term event-based scenario, is we hold the data in cache for a certain amount of time, and then it rolls off into slower storage because we typically don't need to perform operations beyond a certain date. When you think about time series analysis, the vast majority of queries are going to sit in the near term, maybe the last 7 days, last 14 days. In this case, it might be the last 31 days. Well, that way you put your most important data, the most frequently accessed data on the fastest hardware, and you can roll it off onto slower stuff as the likelihood of access decreases. If you keep your log data on cache, you are going to pay extra for that. So if you have a very large amount of data, it makes sense to think through these things. If you have a really small amount of data, I'd just keep it in cache and pay the few extra dollars. Once we've created a database, then it's time to ingest our data. And that's step 3. There are 3 easy ways to ingest data from for a Data Explorer pool. Event Hub and IoT Hub, those are 1 and 2, although really it's 1. I know IoT Hub is functionally a little bit different from Event Hub, but it's so similar that I'm going to treat them as one bigger item. And the other option is have that data already in an Azure Blob Storage account or a Data Lake Storage account. So let's go take a quick look at how that looks. And to do this, I'm going to go home. Here I am. By the way, this is dataexplorer.azure.com. So this is technically the Data Explorer screen for regular Azure Data Explorer. But if we look at data, dismiss, I have the option to ingest data to bring that in. And if I query that data, we have my CSDE, we have my database. We have a free cluster that I created for playing around with. And so inside my CSDE DB, I've got some tables. How do I get data into those tables? Or how do I create new tables? Well, in Azure Data Explorer, I can select data and choose to ingest data. If I want to ingest data, I will choose a destination. So which cluster, I will choose a database, and I can choose either new table or existing table. So let's say some new table or some newtable. Then we'll choose a source. So what is my source? Azure Blob Storage. I could look at an entire blob container, Data Lake Storage Gen 2 container. I could read it from Event Hubs, or fairly recently, I'm able to ingest this from Amazon's S3 as well. So if I want a file, I could choose from my local machine, hey, give me a file and upload it. Or if I have a blob, I can paste in a storage URL. If I have a specific container, here's where things get a little interesting. So if I want just one-time ingestion, I can perform this ingestion pretty easily, just a little bit of click, click, click. And there's also the ability to create an event grid data connection. Event grid is one of the 45 or so ways of Azure to handle events in a system. Event grid is pretty common for application developers, a bit less common in the database space. We tend to think more in terms of event hubs, but it's a lightweight way of transmitting information. And this event grid would say, oh, there's a new file that's been added to this directory. I'm going to send that over to the Data Explorer pool into the appropriate table. We can do this for up to 10,000 blobs. If you have more than 10,000 blobs, you're going to use a tool called Light Ingest. Light Ingest is a console application that you can configure and run to load very large numbers of files. I processed something in the hundreds of thousands of files area, and this worked reasonably well, but it took some time setting up. So if I want to choose a container, then I'm going to I'm not going to be able to pick a subscription, but if I had one in there that it could pick up easily, then it'd allow me to select from it and then choose a storage account and a container. Instead, I can choose a storage URL. And if I pop up Azure Storage Explorer, I'm going to have that on my main screen here. So you won't be able to see Storage Explorer, but I will come up with a URL to a file, which I'm fine with sharing to the broader world. So I'm going to pick my public blob storage container, look at some public data, and I think I'm going to say Chicago parking tickets. That's a good one. This is a sample of 1 million records from, oh, it leads to a blob instead of a container, or the permissions are incorrect. Yeah, so I need to actually go to there to see as public training data. All right, you're not playing nice today, are you? So let me copy blob container, copy direct link to blob container, and let's see if that's going to be nicer. No. So I'll skip this load portion for now. What we'll do is just talk through the concept. Basically, if I pick a file and I'm just gonna pick a very simple data set. Now I'm just scrambling around looking for a file that I can use. But what I was getting at was that we're going to be able to load up a data set, an arbitrary data set, and use it to, here we go. Here's a copy of Chicago parking tickets. Use it to load a new table in our Data Explorer pool. So it's going to upload the file. It's going to do a quick process of the file. We'll be able to check the schema that gets generated as a result of it. And because this is 1 million rows, it's going to take a hot minute for me to upload. Nonetheless, this Chicago parking ticket data set comes from Daniel Hoopmacher, who created a SQL database for the topic. Fantastic data set. It's basically any parking ticket from the city of Chicago, Illinois, from about 1996 through 2017. And I'm using it for a lot of my demos at this point because I think it's pretty cool. So we upload. We'd be able to select the schema, be able to see all of the columns, and then ingest that into a new table. Because we don't have all day for this to finish, I'm going to cancel that and go back to the slides. Is this open data available online? Yes, it is. And let me pull up the link. So this came from Daniel Hoopmacher, and it is a SQL database that you can restore as a backup. It's about 25 gigabytes. I highly recommend it. It's a lot of fun demo database to play with, and there's no protected information. There's no PII or anything sensitive in there. So great database to play around with. Now, when we load data in, we can load it in a variety of data formats. There's comma separated, semicolon separated values, or tab separated values. In the event that you have non-structured text, that would be a standard TXT. So there's a drop down that allows you to select what type of data you have. In addition to these text formats, you also have JSON, Avro, Parquet, and ORC. Parquet and ORC are both columnar file storage formats. ORC has really fallen out of favor in compared to Parquet. Generally, Parquet is going to be where you'll see a lot of the data. Avro is a row store format, which is more optimized, and most likely you're going to deal with some delimited files, JSON, or Parquet. Those are going to be your most likely choices, but there are other options available for importation. Like I mentioned, we can load data for streaming from Event Hubs and IoT Hub, and we got to see that Event Grid is another option, especially if you're using a continuous load from a blob container. When it comes to batch ingestion, usually we're going to do a bulk load from a data lake. So you want to have that data already in your lake as opposed to on your local machine. And this is the preferred method. It does use light ingest, which is that console application that I talked about. You can do up to 1 gigabyte of data, up to 5 minutes of processing, up to 1,000 storage items, so files in a storage account in a batch. Meaning if you have more than 1,000 items or you have more than a gig of data, it's going to say, oh, well, this is another batch. Hang on, let me run that. The good news is, as an end user, you don't have to control that. So you don't have to know how many files makes up 1 gigabyte. All you have to do is say, go look in this directory, this storage account container and keys for driving in, and pick up all the files in there, and it'll batch it for you. Once you have data in, we get to the fun part. We get to querying with the Kusto Query Language. So this is a language for log exploration and is very similar to Splunk's query language. It's a little bit like SQL, but really not like SQL. And something I'm going to call out because I strongly dislike this. It is a case-sensitive language, meaning capital letters where, lowercase letters where, different things. Strongly opposed to that idea, but they didn't ask me before they created the language, so got to go with what they did. The way that it works, though, is that we operate off of pipes. Think of a pipe as a way of, I've got my input, I'm going to send it to another process to perform some operation and generate output. So pipes are the way of linking together separate processes. In this case, I'm going to take my table name and conceptually, this isn't actually how the operations occur under the covers, but conceptually, imagine taking all of the data from my table name and then cutting down to where event type is 14 and the duration is more than 100 milliseconds. So we've performed a filter, but we've got all of the columns in my table name. Then I'm going to use project to select my columns that I want. In set theory and relational algebra, the term project is what they use instead of select. So it's a synonym. And then once I've done that, I will take the top 10. Now in KQL, top requires an order by statement. So I have top 10 by duration milliseconds descending. So that's my kind of a canonical example. This is maybe a table, which is a log table. I'm going to find specific Windows events that show errors, or an event of some sort that has a long duration. I'm going to figure out what that event type is, how long it took, how many events there were in that area, and give me the top 10 of those, the 10 worst offenders, so that maybe I can dig into it if I need to tune queries, if I need to understand what's going on in a process. So what I do want to get at, though, is this is not just for logs. This is a language for log exploration, yes, but it's about more than log exploration. It is about event exploration and time series analysis. And so my example that I'm going to use, it doesn't involve logs at all. It is instead one of my favorite topics, Wake County, North Carolina food service inspections. So if you're not in this area, the Research Triangle Park area of North Carolina, or in the state of North Carolina at all, let me tell you a little bit about what this data set it means. Basically, every county in North Carolina has inspectors who go and visit restaurants, food trucks, school cafeterias, and a variety of other facilities. And they score the facility's cleanliness. The score technically ranges in North Carolina from 0 to 100. In practice, you're not hitting a 0 because they will shut you down long before you get to that point. And we have data collected on date and time of inspection, who the inspector was, where they inspected, the restaurant, the school, the food truck, whatever, the overall score that they got, and some details on what those deficiencies were. So these deficiencies cover things like, say, the server didn't wash their hands before putting on the gloves, or that something was incorrectly handled. The floor is dirty, or these foods were left in the refrigerator next to each other when they shouldn't be because there can be cross-contamination. Those sorts of things. So pretty important if you want to go to a place and not get sick. Do you see any performance issues when we ingest real-time data from Event Hub? Can Data Explorer be used as a serving layer for real-time purposes? Very briefly on that, the short answer is that there is a little bit of time for ingestion. It depends on what you mean by real time. Absolute real time? No, none of that stuff handles absolute real time. But when I say absolute real time, what I'm talking about is, could you put it on a fighter jet and will it kill the pilot? That's real time to me. Near real time, when you're talking 30, 40 seconds, yeah, probably. Probably could handle that. For Log Explorer, typically it takes about 3 to 5 minutes for processing of events. So that gives you an idea of the average window. Depending on how your Data Explorer pool is set up, ingestion can be faster than that. So it might be a minute. And if that's near enough to real time for you, then yeah, it works. But there are some steps involved in that ingestion. It's not literal streaming of rows as soon as they appear. And for performance issues, as always, it's going to depend on things like what your input is. So how big are your records coming in from Event Hub? How quickly are you streaming those events? How many Data Explorer pool you have available to forget that. We're gonna have one consumer really. So it's gonna depend on how powerful your consumer is, how many other people are trying to hit your systems, and factors like that. So too broad to give a really precise answer. Generic answer is you can get data loaded and have it be available for querying within a minute. But let's take a look. Speaking of querying, let's go look at Data Explorer. Let's go run some queries. And I have already loaded up this data. So I've got a few tables here. And we're going to use these tables in hopefully interesting ways. Now, for the purposes of keeping chat alive here, I'm going to move the chat window over and we'll start running some queries. I'm also going to just copy and paste this whole block so that I don't have to keep copying over. So, don't read ahead too much. So our first query, inspections. The inspections table will give us some information on individual inspections. And I'm going to say, give me 10. So take says, just give me a number. Don't order it. There's no sort by. There's no scans involved in this. It's all just whatever the first 10 rows are. Just give them to me. That's fine. And what we have are object IDs. This HSIS ID is actually restaurant ID or facility ID. We have the score, we have the date, and a little bit more information. So, okay, that's cool. Gives us an idea of what the grain of the inspection looks like. Then I can use a where clause to filter. So let's say where the score is less than 90. And I can run this and get back some results. Okay, here's some records that are 88s. So we can see that there are definitely restaurant inspections whose final score is below a 90. Now, I can search for places. Like there's a place in the area called Tropical Pick and Chicken, and it's a good place. If you're in the area, it's some pretty good Caribbean food. So I can use search. And what search does is it says across a table, I'm going to look for this string, and I don't know exactly which row or which column it's in. So just look for anything in any column that may match the name Tropical Pick and Chicken. And we found a name, happens to be on this location. We got its phone number, we know when it opened up, and so on. So we've got some details in here. And I can also use like. Let's say I don't know exactly what the end result is. I don't know exactly what the name was. It's like Tropical Pick, I don't know. I can use a star in my search and run this. Get back. Okay, here's Tropical Pick and Chicken. Like, yeah, that was the name of the place. But let's say I don't remember the beginning of the name. I could still put stars in here at the beginning. Or I could say, I just want any restaurant that has chicken, ends in the name chicken, because if it has chicken in the name, then I'm pretty sure I'm going to like it. So restaurants, search star, search all columns, ends with chicken. And I found there are a few different places that exist here. So we've got a few restaurants that end with the name chicken. And question in chat here, what is the benefit of using Azure Data Explorer versus Log Analytics Workspace? Log Analytics Workspace is specifically for handling log data. So that's for ingesting data from application insights, that's ingesting data from third-party logging solutions, ingesting data from virtual machines on premises that want to send metrics or event log data. So log, it's got it in the name. Azure Data Explorer is more general purpose. It's the same underlying technology, but the intent here is not so much I'm sending you a syslog feed from my Unix boxes, and more of I'm sending you a stream of data, some events that are occurring over time, and I want to perform analysis on this. So this is where I may have a development solution that's performing time series analysis of data. Azure Data Explorer is going to be more fit for that purpose. The pricing wise, I don't recall there being a big difference between the two, but I'd have to go back to the calculator to tell you for sure. And feature wise, there's really not too much that you're going to get in one versus the other. Log Analytics does lock you down on what type of data they ingest and the way that you ingest it. They create, for example, if you're a .NET developer, NuGet packages that I can load up and say, this is my logger. I'm going to App Insights, and that App Insights is feeding into a Log Analytics workspace. And so that's how I can send data there. I don't have a more generic method necessarily of feeding data that I do in Azure Data Explorer where, yeah, pull this data from these different locations. So yeah, main differences. Okay. Our restaurants searching for chicken. We could also say starts with and find all the different alpacas in the RTP area. Specifically in Wake County. There's actually at least one in Durham County. Now, I can also say starts with tropical, ends with chicken. Each one of these pipes indicates a separate filter. So filter 1 completes, filter 2 completes. And I can run those. And so I've got my tropical restaurants, I've got my chicken restaurants, I've got the combination of the two. I can also look at dates. The inspections column or table has a date column and date underscore. And the function ago lets me look at things that are more than a certain time period old. So I can find scores less than 90 and the date is more than 1,000 days ago. There's a fairly robust capability in KQL for handling time, as you would expect from time series analysis. We've got days, minutes, hours, seconds, really going into that level. And it's mostly intended for hour, minute, second type of calculations, but my data is from a little while ago. So I'm not going to be able to look at 30 minutes ago. I mean, I have 12 months ago. But I can go to the day level and I can say here, how many of these rows are there? I did a take 10. So that just gave me 10 results. But now I can use the count operator and go to the next step, indicating there are 345 total rows. By the way, if you're interested in what that caret is doing here on each of these records, I can select the caret and get basically a JPath explanation of this. So I'm able to copy this text if I need to, like I need to paste it into some other system. It's a nice way for me to do that pretty easily. Count is a summary. It's a summarize operation, but there's another way to summarize. In T-SQL, we have the group by clause, and then we have non-aggregated columns, group by aggregated columns. Well, in KQL, there's the summarize operator, and the summarize operator takes an aggregate function. Count is an operator of its own, but it is also an aggregation operation with parentheses. So this is a function. So I can take my inspections, I can summarize and give me the count. This is everything in my non-aggregated columns list. So what do I want to group it by? Well, I want to group it by score. And then I sort or order by score descending. If I run this query, this tells me that I have 3,000 inspections with a score of 100, 4,200 with a score of 99, and so on. And you see very quickly that as we drop below about 95, the number of inspections drops precipitously. So we have very few inspections below 80. Again, the reason for this is if you're that far below, then you're probably getting shut down to begin with. You're failing the health inspection pretty badly. But there's a very heavy skew toward really high scores. There are also 23,000 records that don't have scores in them, and there are 22 that have scores of 0. Those scores of 0 are probably more of an incomplete than actual 0. Let's suppose I don't want to do this analysis at the individual level, though. Maybe I want to bin these. I want to combine these of score brackets, and I can bin and say bin with score and 5. So we're going to round to the 5s. If I run this, basically says I have 3,000 that had a score of 100. I have 19,000 that are 95 through 99, 4,500 that are 90 through 94, and so on up the chain. So bin allows me to create blocks. I can also bin by time period. I could bin it by 1 hour intervals or 5-minute intervals and see my results there. Another way of summarizing data is to use percentiles. And in T-SQL, we have percentile cont, percentile disk. In 2022, SQL Server 2022, we have the approximate percentile cont and disk. Well, these percentiles are continuous percentiles, so percentile cont, and we specify the feature that we wish to create bins out of and what are the percentiles that we want to collect. So here, I can create what is the first quarter, the bottom 25% of scores, 95 is that cutoff. The 50th percentile, the 75th, 95, 99, and the max. So I can do all of that pretty easily in a single operation. I can also get counts. So decount, this is a way of quickly getting counts. The count function is fine, but if you're counting over billions or trillions of rows, you're going to spend quite a bit of time doing this. Decount is an estimated count, and depending on the value that you set as the second parameter here, this is going to tell you how quickly it will return and how big the expected error is. So the fastest is a decount with a value of 0 as the input. This is going to be accurate to within approximately 1.6 percentage points. The default is a 1, which is accurate to within 0.8%, and so on down to 0.28%. So this is the most accurate, but it's also the slowest option. This is the least accurate, but it's the fastest option. And if I run through all of these examples, then what I'm going to end up with is the actual counts and my estimates. And this is inspections summarized by inspector. So I'm doing all of these operations by inspector. And so David Adcock, the actual number of inspections he had was 2477, and we can see the estimates are pretty close. In all of these cases, the estimates are pretty close. They may be a little bit off, a little bit high, a little bit low, and occasionally you'll see a case where the fastest is actually a better estimate than the normal one. But in general, you're going to be pretty close when you're doing a decount. The benefit of decount is it's going to be potentially a whole lot faster too. If I have data in multiple tables, obviously I want to be able to join them together. We have join capabilities like in T-SQL. My join has a kind, left outer, inner, right outer, full outer. And what I'll do is I'll take inspection violations and just grab the top 10. So 10 inspection violations. This is the date. This is the category. Was this a critical inspection error? And we have some of the objects, some of the examples of what deficiencies somebody might write up in an inspection. Dirty walls, bathroom doors are dirty, cleaning dusty ceiling, cleaning soiled flooring. A lot of this is basically you're not cleaning things, you're not washing your hands, that kind of stuff. HSIS ID, I'm going to turn into a string, and then I'm going to join it to restaurants. So I elide it over, turn it into a string. Extend allows me to create a calculated column. I can take HSIS ID, which comes in as a long, and I can turn it into a string. Then I can show the results here. So this is now a string instead of a number. And I can join to restaurants. Restaurants, I'm extending HSIS ID, turning it into a string. And when I return these results, I have the string value of HSIS ID, I have the inspection violation details, and I have the restaurant in which the inspection occurred. I don't have to turn this into a string, by the way. This was an example of extend. So because longs are joinable, I could just as easily do this. We can see that not all the restaurants exist in this data set. There are some inspections for restaurants that are no longer in there, but we do have that data. Because of the more analytical query use case, is it safe to assume Azure Data Explorer provides performance tuning options like Synapse, round robin, hash, or replicate distributions? No. Do we get to analyze and compare query execution plans? Not as such, really. Cluster column store indexes? No. The way the data is stored is intended to be one mechanism that works for everything. Or is it all managed by the service? Yeah, it's all managed by the service behind the scenes. The primary ways in which we're handling performance are going to be, I'll talk about that a little bit at the end, but also caching. So choosing to have that data be cached, that's going to be the biggest avenue for performance. And also writing good queries is my short version. I'll give the longer version as we get to the end. When I join, let's say I have inspections. I'm joining to inspection violations. I'm going to join on the key, and then I can perform other operations. So let's summarize. We'll create a count. We'll get a sum. My summary is on inspection key. But unlike T-SQL, I could potentially have non-aggregated columns in here, even though I'm grouping by inspection key. So I can possibly have non-aggregated columns. Nonetheless, I've got my inspection key. I have number of violations, total number of points. So I could potentially see my inspection key, and then I'll include my other columns in here. So run this, and we have our inspections, we have numbers of violations, total number of points, but we also have the restaurant, the score, and the date. I can make this a little bit more complicated and get things like critical violations, the major issues. So I want to count how many critical violations there were. To do that, I can use the SUMIF function. So SUMIF, here's my if condition, and here's the thing I want to sum. So I just want to have a 1 if critical is equal to yes. By running this, I can see examples of number of critical violations. Here there were 9 critical violations. So this restaurant had a bad day. For facility types, I can use the distinct operator to say, give me the distinct set of facilities. Again, similar to T-SQL in that regard, and we'll get our distinct operations. If I want to figure out how clean these are, I can have inspections and use extend to create a computed column. Then I can filter where the score is greater than 0. Once I filter to where the score is greater than 0, let's join it to restaurants and then summarize and give me the number of entries, the average of score by facility type. And what we can see is that the restaurants are by far the most common, but they're definitely not the highest rated. Turns out that elderly nutrition sites, public school lunchrooms, private school lunchrooms, those are both in the 98s. And then you get down here to food stands and restaurants are at 96. So, by the way, I did just take advantage of one of the niceties of the KQL results pane, which is that, yes, I can filter, I can sort, I can operate off of data that after processing has occurred. So I don't have to rerun the query if I want to sort it a different way. If I limit myself just to restaurants, so I can say facility type is just restaurant, food stand, mobile food unit. I have my join set up and I want to get the number of critical violations and so on. So let's run through here. And we again see our results. So the general flavor of a KQL query, we've got our base table, we might have joins, we probably have filters, we might have computed columns, and we probably are aggregating. When we aggregate, we need a by clause to indicate what we're grouping by. I also might bucket things. I may create buckets. So let's extend and create the month of inspection using the start of month function. And there is an end of month function as well. So now I can get by facility type and month of inspection where the number of entries is greater than 50. We get how many entries there were and what the average score was. And one thing that I can do with this is turn it into a graph later on. I can also summarize and say, okay, facility type month of inspection. Let's add just a little bit here. Let's say where the number of entries is greater than 50 and the average score is between a range. This is how we generate ranges in KQL. So 90 through 95 inclusive on each side. The dot dot is just the between. And looks like I have nothing in here. So no records with at least 50 entries and an average score between 90 of 95. So what we can do is we could find the edges. Let's find out where our inspections are at least 30 entries. An average score is not between 95 and 98. So we've got 40 entries that is above a 98. We've got some that are really high. Actually, in a lot of cases, these are all really high. They're like 98, 99. I'm not seeing anything where it's below 95. Let's just double check that with average score. Yeah, so there's nothing in here. Okay, question in chat. Any performance issues when we join two big tables ingested from Event Hub? The ingestion point doesn't matter because the data gets brought into the Kusto database. So you're not directly reading from event hubs. You're ingesting the data and then you're querying that ingested data. And two, support to ingest data from Stream Analytics into ADX. I'd have to double check on Stream Analytics. I don't recall offhand if you're able to ingest directly. I believe the answer is no, but that's a belief, not a guarantee. And worst case, if you had Stream Analytics and you wanted to take the results, I mean, you could feed it into another event hub and then ingest from there. But I suppose part of the question would be what your end goal is in performing the Stream Analytics operations and if they could be done in KQL more effectively. Now, let's make this look just a little bit nicer because I've got facility type. I don't like the differences in casing. I don't like the fact that this is uppercase, this is Pascal case. Maybe I want to have something that looks also a little bit nicer in terms of date. Like I know I don't have the times. None of these have times, they're months. So let's do a little cleanup. I can format date time and say, format my dates in this style. I can average out my score to just 2 spots after the decimal, so I don't have artificial precision of like 9 spots after the decimal. And I can rename. So I can do all of this stuff with project with my select. So what's the largest number of violations by facility type? Let me first show you this query. This is my inspections. I'm extending that out, including HSIS ID. I'm joining, I'm summarizing. So we've seen all of this stuff before. Let's see what this is doing. What this is saying is by facility type, so like push carts, we're going to get the record that had the highest number of violations for that facility type. So our granularity here is per facility type, and we found there is a restaurant that had 67 violations. Cinebistro and Carry apparently had 24 critical violations. So if that other one had a bad day, these folks had a really bad day. But I can see what is the worst scenario, what is the best scenario, what is the most interesting case grouped by something else using argmax. And similarly, there is an argmin. So let's find what is the lowest score by facility type where the score is greater than 0. For a public school, the lowest score was actually a 91, and that was a Fuquay-Varina middle school cafeteria. As we go down, we can see other cases like restaurant was a 70. So, we get argmin and argmax to say, give me the record which matches this scenario, grouped by something else. And let me dive in just a little bit further. So we're going to pick one particular inspection key sorted by criticals. And these folks had quite a few inspection issues, and whether they were critical, I'm going to have to scroll back over and say, yeah, so they had a lot of critical inspection errors. And we could dig into the comments. Pans are not clean. The noodles are heaped together incorrectly. Nobody was in charge. Stuff. Employees do not wash their hands. Stuff that you don't want to hear in a restaurant. But we can check out all of their inspections. We know their restaurant ID. So I'm going to pick that restaurant ID and say, what did their inspections history look like? Are they always that bad? And if I look by date descending, what I get at is that, no, they're not always that bad. I mean, typically they're a little bit higher. They've had a bad instance here. They had a bad instance here. So then this one was an 88. That was even worse. This was a 75. That was terrible. So they've had some awful situations, and they've bounced up and down a bit. I had to hard code HSIS ID here, but I can also use the let keyword to say, let restaurant ID equal to this. Let essentially is set this as the result of some operation. That operation is happening on the right-hand side. In this case, it's just create a variable. But the thing is, if I just run the operation, I get this error. Each let statement has to be followed by a tabular expression, an expression which returns a table. So I cannot create a variable and then do a bunch of stuff and then come back to that variable later. This is not like C# or F# where I can define variables and have them holding up in memory for a little while until I want to use them. Instead, we have to use the variable at the time. So here's my restaurant. I have all of the cases where the restaurant is that ID. I can use previous and next to act as lag and lead. So here's my restaurant ID. For that restaurant, sort by date and say, what was your prior score? What was your next score? What was the score 2 from now? So this is prev and next. If I run this, we'll get the equivalent of lag and lead in T-SQL. So I have a little cascading waterfall effect where we see like 98 here, 98, 98, 98. So over the course of 4 months, we see that date that value flow through. I can use top nested. Top nested is really cool because top nested is going to say, give me the top 5 and then everybody else. So top 5 inspectors with all others based off of the count. And the question was, is there a construct like a temp table or table variable, staging table to capture data sets in memory? In memory, you can set table results. Like I could set this. So let top 5 equals inspections. And then I could say, let's say sort by inspector. So I could run these two together, but what I can't do is set this and then later on access it again. So it has to be all part of the same continuous query. there's got to be a query which results in a table. Like a table variable. Yeah, you can think of it that way because it exists over the context of the execution. It's not permanent. If you want something to be permanent, you can write that data into a table and then query that table on a later date. But that would be sort of like writing to a permanent table in T-SQL and then querying that permanent table later. So I'll scroll down just a little bit further because we have top nested and then sort. And I do want to mention materialize. Materialize is another way that we can save data sets. So to Daniel's question here, this is useful if you have multiple calls. So I have inspections, my top 5 inspectors, and I can materialize that table. So let inspectors equals materialize, and then run it. And I can also run inspectors, union inspectors, like 2 queries. Materialize is still effectively like a table variable, except it's a table variable that's written out. And if you have complex processing to generate this, then you're not rerunning the complex processing. But it still only exists over the scope of the execution. So it still disappears once the execution's done, which means it's not a permanent table. If I have multiple tables, I can hit the drop down here and we can see our union of results. So multiple results. I also have some stats. There were questions about, can I get information about execution plans and the like? We can at least get some information on how much memory we're using, data set sizes, did we hit from the cache or did we have to go out to slow disk, and a little bit of the JSON results. But we're not seeing execution plans. And we're not seeing things that as a data platform specialist, query tuner, I might really love to dig into. KQL is not really intended for that kind of scenario that we would have in a relational database. It is a little bit different in its main angle of what they want to show you. So briefly, because I know we're close to time, I've got about 4 minutes. So I'm going to walk through code and just do a couple of quick things. So I ran this a little while ago. This gave me information about one particular restaurant and their stream of time of data over time. I can render this result. I can render as a time chart, and using render allows me to build a graph. I could build a graph otherwise. I can use the table here, and I can generate a graph out of this. So, but in code, I can say render and then spit out the results, and we can see that there's a bit of bouncing up and down. We can also build out ranges of data. So I can build a range from 1 to 8, step 1. So that's 1 through 8. Building over time, so you don't have to have special ranges, and dates over time. So what is a real world use case of KQL? We can ingest and transform the same data using Spark, like Spark streaming. Yeah, sure, you can. I mean, it's another language that is intended for event-driven operations. Spark streaming will work in those cases. If you're more comfortable with writing Scala code or Python code, it's certainly a viable option. With Data Explorer pools, the main benefit that you're going to look at here is that I will have the ability to process logs, which you can technically do in PySpark or Scala-based Spark, but it's not as comfortable. And also getting into things like time series analysis, where I want to get, think of my case of my top 5 and group by all others. Or as I dig in through here, I want to say, give me a range of results, how many inspections each inspector does over a 10-day period. I'm able to do that by making a series in KQL and generating those results and be able to analyze over that. So we have numbers and inspections by date, and then I can graph this. I can see that my results when I render this indicate that these are state employees, so they don't work on weekends. I'm also able to drill in a little bit further with the language, look at longer time frames, and turn things into analytics with a query versus slightly more complicated code. So I have things like min, max score, average score, standard deviation and variance, sum, etc. All of these functions are operations off of series stats dynamic, which is a nice function that's built into the language. Because I did promise a little bit on query recommendations, let's talk about that. Microsoft does have guidance, and let me pop up the link to this. You know what? I will skip validation because there we go. So this is Microsoft's query guidance on how to write good queries in KQL. Short version, use filters first, especially if they're time-based. Where your filter placement does matter. With SQL, the optimizer can shuffle things around a little bit to find the best path. With KQL, order is important. Filter before project, before extend, before join, if you can. Make sure to use case-sensitive operators. You can run into problems otherwise. Search in specific columns, not across all columns. I did show you the search capability that technically can look across all columns in a table, but if you know which column you're looking for, focus on that one. That's going to save you some time. If you have complex calculations and you're running things repeatedly, Materialize can simplify the process. And remember to use take instead of top if you don't really care about the specific ordering. Microsoft has guidance on query limits. So that's another link. And by default, there are some limits. Let me drop this in here. Those limits, no more than 10 requests per vCore. So if you have 10 concurrent requests, you need at least one vCore to support them. Result can have no more than 500,000 records come back or 64 megabytes come back by default. You can change those defaults. Max memory consumption per operator is 5 gigabytes, and that's to protect runaway queries that just knock over your server. Server timeout also exists. That is configurable. So all of these things that I mentioned here are configurable, but there are blocks that are put in place to help prevent one query from having a nasty effect on your server and possibly knocking it over. So wrapping things up, if you want to learn more, if you want to grab these slides, if you want to get links to additional resources, if you want to get the demo data that I have, check out csmore.info/on/synapse_KQL. If you have any questions, email address, Twitter handle are right there. And it looks like there were a couple of questions here. Okay, like if we need to ingest the data from Event Hub, we need Python coding to get the data into Kusto DB. Not really, no. No, Sanjay, you don't need Python at all for ingesting data from Event Hub. The ingestion from Event Hub into Data Explorer pool or into Azure Data Explorer, that's just a handle that's set up. Analysts can make use of the data once it's in the database. So for Event Hub, that scenario is really easy. There's no special coding required. It sounds like KQL is leveraging some T-SQL functionality, like window functions, top in, etc. Yeah, the language intentionally follows some of the practices from SQL because SQL is the best language for data-specific operations. It is the best domain-specific language for data. So to that extent, it's a good thing to copy as much as you can from the language, and then make your own twists based on your particular genre. For KQL, it was intended to fit in that Splunk area of log analysis, which is a combination of time series and detailed dive into text data, search on text. And so that's where a lot of the special functionality in KQL ends up. I'm wondering if this would be applicable for high-level financial reports because it deals more with crunching numbers. Potentially. If I'm thinking financial reporting, I'm probably still living in a SQL database. By default, I'm always concerned about the correctness of results, and for streaming applications, there are too many things that can go wrong for me to be completely fully trusting of them. I tend to be a little bit of a curmudgeon in that way. But if it's like general trends, what's going on right now, streaming of here are the most recent products that are selling, that kind of stuff, then yeah, KQL could be a really good choice for this, where you're getting a stream of all of the events that are happening in your company and you just want to get a feel for what's happening versus reportable numbers that you're going to send to the SEC or to some other regulatory agency. Then KQL or Data Explorer pools could be a viable option for getting that information. One of the areas I really didn't dive into at all was its integration with Power BI. So you can use KQL or the Kusto database as a source in Power BI for streaming inputs, meaning that you could get those near real-time-ish updates for your Power BI online reports. So that whole pipeline is something that Microsoft has been very intentional about and is part of why the Data Explorer pool is part of Synapse. But with that, I think we've wrapped it up. I've stolen 5 extra minutes of time. I appreciate everybody's time today. I appreciate all the great questions, and I'm going to hand it back over to Jean and say thank you so much, everybody.
Thank you so much, Kevin, and thank you to all attendees. Just for your information, if you haven't registered for Feature Data-Driven Summit 2022, now this is the time to do it. And if you do like to submit a session, feel free to do that. And if you want me to schedule you to our weekly user group, let us know. We'll be happy to schedule you. This session is being recorded and it will be available to our YouTube channel sometime 6 p.m. EDT. Thank you to all of you one more time, Kevin. Thanks for your presentation, and we can't wait to have you next year.
All right. Thank you.
Great.